All right, seventh graders, so far this unit, we've been using a number line to compare positive and negative numbers, and that's a really great model, a great tool that we have been using. Today, we're going to be talking about a new model that you will use for positive and negative numbers, and that's what our focus question is telling us. It says, how can you use a chip model to represent the addition and subtraction of, positive and negative numbers? The chips that we are going to be using are these red and black circles. Anytime that you see a red circle, you know that that stands for a negative number. And anytime you see a black chip, that stands for a positive number. If you have one red chip, then you have -1. And if you have one black chip, then you have +1. These two numbers right here are really important to us. They are the same distance away from 0, just on different sides. We call those types of numbers opposites. Opposites are special because we know when we combine them, their sum is always 0. We know that +1 plus -1 equals 0. This is really important for us to remember as we're using a chip model, because that means anytime you have one black chip and one red chip, they are going to cancel each other out because they make 0. Let's use that as we review the chip model that we used in class. In class, we said Tate owes his sister $6 for helping him cut the lawn. He earns $4 delivering papers. Is Tate in the red, meaning does he owe money? Is he in the negatives? Or in the black, is he in the positives and has earned money? If we take a look at his chipboard, then I see 6 red chips, which stand for the -$6 that he owes. I also see 4 black chips, which stand for the $4 that he earned, the 4 positive dollars. If I want to figure out what his combined value is at the end of the day, how much money does he have or owe, then I can look at those pairs of opposites like we just said, because one black chip and one red chip cancel each other out to make 0. So if I stack up my pairs of 0 just like that, what's left over that doesn't cancel out? I have these 2 red chips, meaning right now he owes -$2. It's really important to be able to take that information that we just showed and write it as a number sentence. So let's review. We said he started with -$6 that he owed his sister. We combined that with, or added that to, the +$4 that he earned delivering papers. And with the chip model, we just showed that that equals -2. He still owes his sister -$2. We also want to be able to use a chip model to represent what happens when we add chips to the board and take chips off the board. So first, let's figure out what is the value of my chipboard right now. Well, if I look at those pairs of opposites that we were just showing, I can stack up one black with one red, one black with one red. And what am I left over with? One black chip means that my chipboard is showing +1 right now. Okay, first I want to add 3 red chips. I've got a stack over here, so I'm going to add 1, 2, 3. In other words, in my number sentence, what I just did was I added -3, because each of those red chips stands for a negative, okay? What's my value on the chipboard now? Well, I have another pair of opposites that I can cancel out, and what's left over? 2 red chips, meaning when I had +1 and I added -3, I just showed that that equals -2. We also want to be able to represent what happens if we take things away, meaning removing chips. All right. So if I show this, I know that right now my chipboard represents -2, and I want to remove, meaning subtract, +4, 4 black chips. Okay. And I'm going to figure out what does that equal. Well, here I go. Let me take away 1, 2, 3. Hold up. I don't have a 4th chip that I can remove right now. So how can I come up with a 4th chip to take off my board? Can I just add another black chip over here? No, because that's just adding 1. I can't just add 1 because I feel like it. What can I add that won't change the value of something? I know that adding 0 never changes the value. So here's a trick that you're going to have to remember. If you need to take away extra chips, you can add a pair of 0 because that doesn't change the value. And now I have a 4th black chip to take away. So I just showed that -2, and if I take away 4 black chips, what am I left with? I'm left with 6 red chips, meaning -2 minus +4 equals -6.